In this topic, we are discussing the basic idea of the three-phase induction motor using voltage and frequency method. This is the last topic of the chapter 6, that is motor, and also the last topic of the power electronics subject. The induction motor are popular due to the following advantage: that it is simple and rugged in construction, cheaper in cost, maintenance free, and can be operated in polluted and explosive environment. It is self-starter motor, and as we discussed in the previous lecture also, that it has a very high efficiency, that is about 94%. And for any motor there will be a two main part, that is stator and motor. Like this, induction motor has also the two main part, one is stator and second is rotor. The speed of the three-phase induction motor can be controlled from stator side and rotor side. The main method for controlling the speed of induction motor is by changing the number of poles, stator voltage control, voltage and frequency meter, and rotor resistance control. So how we can control the speed of the induction motor? By changing the number of poles. It is used for the squirrel cage rotor motor only. It has the number of stator poles can be changed by the three method. One is the multiple stator winding, second is the method of constituent pole, and third is the pole amplitude modulation. Now we have Ns is equal to 120 F upon P. Ns is the synchronous speed of the frequency and P is the number of pole. So by changing the number of pole, we can synchronize the speed of the induction motor. Second method of controlling the speed of the induction motor is the stator voltage control. In this, the torque is directly proportional to the stator motor. It is very easy and cheap, but still we are not using this method. We are use this method rarely. By decreasing the voltage, torque will reduce. Increase current in motor, which will heat the motor and causes loss. That is why we are not using this method, and we will use this method very rarely. Due to the first point, large voltage change is required for changing the torque. Now, by the voltage frequency control method, the synchronous speed is given by the 120 F upon P, and V is equal to voltage is given by 4.44 phi FTA. Phi is directly proportional to the voltage and it is inversely proportional to the frequency. So V is the voltage, phi is the flux, F is the frequency, T is the number of turns, and K is the winding constant. As we increase the frequency, the flux will decrease, and because it is inversely proportional to the magnetic flux, or magnetic flux is inversely proportional to the frequency, and if we increase the voltage, the flux will increase because it is directly proportional. So keeping the by keeping the voltage and frequency constant. Now the last method of controlling the speed of the induction motor is the rotor resistance method. In this, the torque is directly proportional to the slip upon the rotor resistance. We have discussed in the previous lecture about the slip, definition of the slip. In this method, the method is used for wound rotor motor only. In this method, the speed of motor can be controlled by adding external variable resistance to rotor via slip ring. It can also use as a starter. It is a simple method. Resistance means heat and heat means losses, and if any motor will produce the losses, it means that it is less efficient. That is why we will use this method very rarely. This is all about this topic and all about the chapter 6, that is motor.